Hi everyone, welcome to the week 3 of the bootcamp, Connecting Things. So in this week assignment, we have to create a new AWS account following the AWS Security Reference Architecture, build a VPC from scratch using Terraform, manage changes to our VPC using GitHub, automatically deploy changes using GitHub Actions, and then share the VPC with other accounts using AWS Resource Access Manager. So let's dive into it. I created a diagram. So it's me who's pushing some code from Visual Studio Code to GitHub repo, which will trigger GitHub action pipeline, which will run some commands in Terraform. And the commands are just Terraform initialize and Terraform apply. Now that will create a VPC with two public subnets, two private subnets for route tables, an internet gateway, and also it will create an AWS Resource Access Manager, which is used to share the VPC from OU infrastructure, from the network account, to our other OU sandbox. All we want to do is just share the VPC with the developer account. Now let's go to the next part. Here is my organization, and as you can see, I created the infrastructure organization unit, and within it, I created the network account. And we still have the Paul Syrian, the management account. Now let's go to the network account, and within the network account, we have our VPC, which is called VPC network account. And if we go to the resource map, you can see here that we have a VPC, 4 subnets, route tables, and then an internet gateway. And the internet gateway is connected to the two public route tables. Now let's move forward. I just want to show you the code from my GitHub repo. So we're in my GitHub repository, and we have few files. We have the variables files. I will just start with this because I want to show you and explain to you what's happening here. So in the first one is just the variables for side range for the VPC, then the variables for private subnet. So within it we have a type, and it's called list of objects, and we have 3 objects within it, which is the name of the subnet, the side range of the subnet, and the availability zone of the subnet. And as you can see, we just have 2 blocks of code which will create 2 subnets. And so it is in the public one. And then in the organization unit, we have a variable called OU, and that will be for the ARN from our sandbox. And then the variable for Resource Access Manager, and it's just the name of it. Now in Ram we have the resources we have to share, and that's the subnets. And then we have the principal association, so as with what we associate the resources. And then we have the 2 resources we want to share, which is the public subnet and the private subnet. Then if we go to the VPC, in the first block of code we have the VPC configuration, not big of a code. Then we have the private subnet, and as you can see we just have a single block which will create 2 subnets. And I just use the meta argument called for each, and I will just loop through the subnets in my variable private subnet, and it will take all the subnets like subnet name, subnet side range, and subnet value of the availability zone. I will just create as many subnets as I put there. Now I could have done 4 instead of 2, so we will create the private one and the public one. But in the public one I just had to add this block of code when I will create an EC2 in my public subnet. So we will just map a public IP to that EC2 instance on launch. And then we have the internet gateway and the route tables. We have the route tables public for the public subnets. And as you can see, we have the routes, which is routing from the internet gateway to the internet. And also we have the route tables for the private subnets, and we have the meta argument again for each, which does exactly the same. It just goes, checks how many subnets, private subnets do we have, and then it just creates as many route tables. So we have the route table association for the private route tables, and then for the public route tables is just here. So what this does, it just loops through the private subnet and through the private route table, and it will just create for each and every one of them. Now this is all with the GitHub configuration. Let's go to the GitHub workflow, and it's just a simple workflow, which is connecting to Terraform Cloud through a token, and then it will just initialize Terraform and then run apply. So we are in Terraform Cloud now, and we go to the variables, and we have two sets of variables. Those are for the role in AWS. So with this, we just link the Terraform Cloud to AWS account. And then we also have a variable called OU, and that's for the ARN from the organization unit. So when we had to pass the variable from resource access manager to the, where is it? Yes, here. So we had to specify the ARN of the organization unit to share the resources with. So instead of just hard coding the values here, I just created a variable and put it right into the Terraform Cloud. And this is the one. Now just be careful with this, because it got to be a category Terraform. I had a bit of a headache trying to create an actually environment variable, and it didn't work. So in the end, I just found out that I should create the Terraform variable, because obviously it's for Terraform, but hey, we keep learning. And yes, that's it for now. Now I just want to go to my developer account, and I will show you the resources created there. So I'm in the developer account. We go to the VPC. We take the VPC, and as you can see, we have the VPC created. Now to prove that it was with the VPC is from the network account, you can just see here that this owner is the 324 whatever account number, and is shared. And if we go to this picture, you can see that the network account starts with 32403 and so on. And then if we press on the resource map, again, you can just see that all the public subnets, they go to the internet gateway through the route tables, and the private subnets, they have their own route table as well. And this concludes our demonstration. So we created the AWS account, as I showed you. We built the VPC from scratch using Terraform. We manage changes to our VPC using GitHub, automatically deploy changes with GitHub Actions, and then share the VPC with other accounts using AWS Ram. So why is it important for us to know all these things? It's just because if you have, let's say, 10 or 20 AWS accounts and you have to create VPC in all of them, when something goes wrong, you will have to troubleshoot, and you will have to go through each and every AWS account to find the problem, where the problem is. But if you use this, you will just create one VPC within one account, and that's how you share it with, like, you use AWS Resource Access Manager to share it with other accounts. And if you know that the problem is with the subnet, with the internet gateway, or route tables or the VPC, you just go in the network account and you fix the problem there. Thank you very much for watching. Until the next week.